Here's a question I often ask myself in the middle of the night. How can I make alcohol? Here it's phrased a little differently. It's how can we make alcohol? So there are several methods to arrive at the functional group OH. We can do hydroboration oxidation. We can do oxymercuration reduction. We can do acid catalyzed hydration. We can do hydroxylation with osmium tetroxide. We can do reduction of carbonyls with hydrides. In this video, I'm going to cover the reduction of carbonyls with hydrides. So the hydrides we use are sodium hydride here and calcium hydride here. So this is nucleophilic and a reduction. Sodium borohydrate and lithium aluminum hydride are reducing agents, this one being the sledgehammer and this one being the weaker reducing agent. So we start off with an aldehyde, C double bond OH, and we reduce it in the presence of sodium borohydrate, methanol, and an acid workup, and we get a primary alcohol. So aldehyde to primary alcohol. Ketone to secondary alcohol. Notice, same reducing agent, sodium borohydrate, methanol, plus the acid workup. Now, if we have a ring with an alkene and a ketone, we have to use the sledgehammer. That's lithium aluminum hydride. Diethyl ether, 0 degrees Celsius, and an acid workup to reduce it to the corresponding secondary alcohol. Another way that we can get alcohols are by the reduction of esters and carboxylic acids. Now for these guys we need the sledgehammer, we need the strong reducing agent, that's lithium aluminum hydride. Diethyl ether, 0 degrees Celsius, and an acid workup. And we get, for an ester, we go to primary alcohol, plus the byproduct in this case is ethanol. For the carboxylic acid, we go again to the primary alcohol. We can also get alcohols through Grignard Chemistry. So we're starting off with an aldehyde, and this compound, this is the Grignard reagent, to give us this gives us a secondary alcohol. Now if we start off with a ketone and in the presence of Grignard we get a tertiary alcohol. So aldehyde plus Grignard, secondary alcohol. Ketone plus Grignard, tertiary alcohol. Next question is, how do we make ethers? So there are just two ways to make ethers. There is the Williamson ether synthesis and alkoxymercuration reduction. So Williamson is to start with an alcohol, react with a strong base and alkyl halide, where the halide is the leaving group. Like you see here, you're starting off with butanol, you react with a strong base, which is NaH or NaOH, and you also have an alkyl halide. In this case we have benzoyl iodide, I think it's called. So this is the iodine is the leaving group. So you see we still maintain the OH, the H leaves, and we just add this compound on here. So we wind up with an ether. The next way is alkoxymercuration reduction, as shown here. We start off with a terminal alkene, and we, in the presence of I don't know what this is, but methanol, sodium borohydrate, and mercury something, and you end up with a methoxy group added to the more substituted carbon of the alkene. So this right here is an ether. So ROR. Next question is, how do we make epoxides? So first way to do it is with peroxyacids. In this case we have MCPBA, which is short for metachloroperoxybenzoic acid. So cycloalkene plus metachloroperoxybenzoic acid, and we wind up with an epoxide. So with an epoxide we just have a ring. This is a kind of ether, but it is an unstable ether due to the steric strain. The ring wants to open up. Next way to make epoxide is through intramolecular Williamson's ether synthesis. So again, cycloalkene plus Br2 in the presence of H2O, and we get a halohydrin intermediate with an OH and a Br. The Br is then a leaving group in the next reaction with the presence of NaOH and THF. I think this forms NaBr, and you get another OH here, and then the OH collapses, and then you have like a dehydration kind of thing going on, and then you get this epoxide. That's what I think. How do we get amines? How do we make amines? So there are how many? 1, 2, 3, 8 ways, 8 different ways to make amines. So first one is the reduction of nitriles. We have a nitrile group. We need the sledgehammer reducing agent, lithium aluminum hydride, in the presence of diethyl ether and acid, and we get the corresponding amine. Reduction of azides. When you see azides, think N3. So we have N3 being reduced to NH2 in the presence of the sledgehammer reducing agent again. Next is the reduction of amides, but yes, the reduction of amides. So this whole amide group is being reduced to the amine group. Continuing with how to make amines, reduction of nitrobenzene. So we start off with nitrobenzene, and this should be a benzene ring, so there should be a, I think this is what it should be. There should be that thing there, resonance for a benzene ring. Nitrobenzene being reduced in the presence of iron, hydrochloric acid, and hydrogen, different kinds of hydrogen with palladium or rainy nickel, whatever, to the corresponding amine. So the nitro gets replaced by the amine. Gabriel synthesis. Gabriel synthesis takes place in the presence of strong base, ethanol, and this is an SN2 reaction. We end up with an amine group here. I'm not quite sure how this mechanism happens, but next video maybe I'll figure it out. Continuing with how to make amines, reductive amination. You start off with a ketone or aldehyde, and you end up with a primary or secondary amine. In this case, you have a ketone and you have a secondary amine. So ketones go to secondary amines, and aldehydes go to primary amines. The Hofmann rearrangement. So you have an amide. Start off with an is that an amide group? Yes. Start off with an amide group, and in the presence of Br2, NaOH, H2O, we get the amine. But notice there are 1, 2, 3 carbons, and there are just 2 carbons on this amine because their CO2 is being given off as a gas. So we have in the products a product of 1 carbon less than we started with in Hofmann rearrangement. In Curtis rearrangement, we have the same thing, where we have a 3 carbon going to a 2 carbon amine in the presence of NaN3 and ethanol and heat and water. N2 and CO2 are released as byproducts. So Curtis and Hofmann. Hofmann, you get CO2 as a byproduct. In Curtis, you get you get nitrogen and carbon dioxide being released.